So in exercise 4-1, you actually solved a system of linear equation. So we have the two equations, 2x minus y equals 10, and then x plus 3y equals -9. So I'm just going to label these equations 1 and 2. So one technique to solving a linear equation is to eliminate one of the variables. Now, in order to eliminate the variable, you're actually going to be adding two equations to each other. Now, when you're doing that, when you're adding the equations, you're adding with the hope of eliminating one of the variables. So you actually want to make one of the variables have the same but opposite signs of the coefficients, so that when added, it'll add up to 0 and the variable will be eliminated. You can also just make it the same coefficient and then subtract the two equations by from each other. So we're gonna do the first method and make and add the equations together in order to eliminate the variable. And to do that, it looks like it would be easiest to eliminate the y variable. So first we're going to want to take equation 1 and multiply it by +3. Like, multiply each term by +3. So we're going to get 6x minus 3y equals 30. At which point we can take the second equation, x plus 3y equals -9, and actually just add both equations to each other. So we have 6x plus another x, so it's going to be 7x. -3y plus 3y is going to get 0y, which cancels the y variable out. And then adding 30 and -9, we're going to get 21. So then solving for x, we get x equals 3. At which point we can substitute x equals 3 into either equation and then solve for y. So substituting into the second equation, substituting for x, we'll have 3 plus 3y equals -9. So then subtracting 3 from both sides, we'll get 3y equals -12. Then solving for y, we get y equals -4. So now writing this solution as an ordered pair, we would get 3, -4. So basically, at x equals 3 and y equals -4, both these equations are true. So the reason that we write the solution as an ordered pair is because when we're solving for x and y, if we actually graph both the equations, this here would be equation 2, and this would be equation 1. The intersection of the two equations will be right here at the point 3, -4, which is the solution to that system of equation. So that's why we write it as an ordered pair. So for this next one, we're going to want to eliminate one of the variables again, but to do that, we need to get both the coefficients of x or y to be equal to each other. So this one's like, it's not as simple to just make the coefficients the same, but if we multiply this equation by 5 for each term and this one by 3, we're going to get 15x for each term. At which point we can now eliminate x. So we're going to multiply each term of this equation by 5. So I'm just going to write times 5. And to do that, so when we do that, we're going to get 15x plus 20y equals 30. And then for this equation, we're going to multiply by 3 for each term. So I'm going to write times 3. So for this point, at this point, we get 15x minus 21y equals 42. Now that we have the coefficients the same for x, we can eliminate x by subtracting one equation from the other. So subtracting this equation, we need to subtract each term. So 15x minus 15x will get us just 0. 20y minus negative 21y is the same thing as adding the two, so we're going to get positive 41y equaling, and then 30 minus 42 is going to be negative 12. So then, solving for y, we're going to get y is approximately negative 0.29. So now that we've solved for y here, we can plug it into either equation to solve for x. So I'm going to substitute it into the first equation because it's a little bit simpler. So we're going to get 3x plus 4 times, and here's y, which is negative 0.29, and that's going to equal 6. So then solving for x from here, we're going to get x equals 2.39. So we can now write the solution to this system as an ordered pair, which would be 2.39 negative 0.29. So for the next problem, we want to solve this the system of 5x plus 2y equals 10 and 5x plus 2y equals 20. So subtracting the second equation from the first, we need to subtract each term. So 5x minus 5x is going to equal 0, and 2y minus 2y is going to equal 0. So really we're going to get 0 equals, and then 10 minus 20 equals negative 10. Although this is not the case. So really the solution set to the equation is no solution, meaning that there is no intersection between these two graphs. Now the reason we know that also is if we put these equations into slope-intercept form and by solving for y, so we'll get 2y equals negative 5x plus 10, and then solving for y, we get y equals negative 5 halves x plus 5. And then this one, solving for y, we'll get 2y equals negative 5x plus 20. And then y equals negative, whoops, this shouldn't be negative 50x, this should be negative 5x. So then solving for y, we'll get negative 5 halves x plus 10. So these equations are actually parallel to each other because they have the same slope. They have different y-intercepts, so we know they're parallel. So for that reason, they're never going to intersect, and that's why there is no solution to this system. So, when this concludes this section on the beginning of solutions of systems of linear equations. So the process of adding or subtracting two equations from each other to eliminate a variable is actually called linear combination. So, and you've probably heard this before being called elimination because you're eliminating a variable, but really all you're doing is you're adding or subtracting these two equations and linear combining them in order to get a simpler equation in which you can solve for one of the variables. Now there are other methods of solving the systems, like in previous courses you've probably heard of the substitution method, as well as the graphing method, in which you can graph the two equations and analyze their intersect that way. So you'll probably, in the homework, you'll probably encounter problems where you can use either of these two methods, and really it just comes down to whichever would be the simplest method to solve the system.